I cannot speak for another faculty questions. So I tried it, but then again, I was instructed not to. So you need to ask the person who wrote the question, take your concerns to the faculty who wrote the other 27 questions, okay? So mine started out of 18, there were 3 questions which I adjusted the grid so that all of you, most of you, you got, whoever got them, they will be, select all that apply. I said, accept any combination. There was a question on weight loss. Weight loss, it is a tricky answer for you. You know, the loss of appetite is one of the symptoms of hepatitis. People suffering from hepatitis don't feel like eating, they are vomiting, nauseating situation. The weight loss, you can say loss of appetite safely. They cannot, they don't like any food smell or anything. Weight loss is a tricky answer. See, weight loss is, if they don't eat, normally they lose their weight. It so happened to our German Shepherd, she had a reaction, she was on cyclosporine for some conditions. It created the liver problem, the liver enzymes went up, and she couldn't eat, so she's vomiting, nauseating, so she lost weight. So that happens. But imagine a situation, with my chronic hepatitis condition, it can accumulate ascites fluid. When that situation happens, person actually gain weight, right? You cannot say loss of weight loss is a symptom, because it can be because of the fluid buildup. Person gains weight even though he or she is not eating. So loss of appetite is the best symptoms, but since you guys were told in the therapeutics, so I will stay with that, respect it. So I gave credit even if you had selected weight loss, I said, okay, accept it. So that's one question. The other one was about the semi-career. Semi-career, we are going to talk about that today because it's not a prodrug, so that is the only not a prodrug option. That was the question. Then there was another question which I gave you credit for. So 3 questions, I can't remember what that, unless some of you know what that question was. If I have time, I will open the exams up after the class. So I will show you what I adjusted in your grades. Okay? Now, today we are going to continue hepatitis and cirrhosis. Now, since we talked about pathophysiology, pharmacology of this condition, now we are going to talk about the chemistry of the drugs which are used to treat the condition. The learning objective here will be identify the main chemical classes of drugs used to treat hepatitis and cirrhosis. You already know those drugs better than me. Evaluate the chemical properties. I'm here to help you, assist you to understand the chemical properties, why this one is appropriate, the other one is not, because of the chemical structures, functional groups, modifications. Then distinguish any adverse effects of these drugs. It's a short class, I think that there are 14 slides. We should be done pretty good, like a half hour. Then I will open up the exam stuff. I'll show you my portion of those 3 questions I adjusted. Someone asked me, how do I study for these chemistry part? It is compare contrast. As I mentioned earlier, other day, all these drugs, the ones which we are going to talk about, adefovir, entecavir, lamivudine, tenofovir, what are they? What is similarity between these two? That's what I would list the similarity. There is plenty of similarity. What's the difference? There's differences of fewer and fewer. That's what makes you, if you know the differences, it makes you better knowledge able person. You can teach your peers, hey, this cannot be used, this is because of so and so. It happens in the preceptors when you are doing internship or rotations. So you will be, if you know these chemical differences, you will be better off. You will even impress the preceptors. When I was teaching in U of A, one day we had a gathering. There was a guy. I thought it was a headstrong comment. There is a medical doctor. He comes and sits right next to me. Then we got introduced. And he asked me, "What do you do?" I said, "I'm teaching pharmacy students in U of A." Then he said, "Oh, those students who come in, they know nothing." That's how the comment was. I thought it was ridiculous to ridicule the whole population of pharmacists. They don't know anything. They come in just with that. So that's how they were capitalizing that. It was 96, 98, 2000, 1996, 98. So, but pharmacist's role has changed a lot. When I had my knee surgery, there was a pharmacist doing the rounds, going with the doctor and the nurses, and the doctor was turning to the pharmacist. What do we give this guy? That's how they are, depending on your opinion, to prescribe their medications. So that you know everything, the pharmacology, pathophysiology, everyone knows. Doctor knows, nurses know. However, doctors and nurses do not know the chemical properties. That's where that makes you pharmacist unique, and they depend on you. Okay? So compare and contrast. Get the similarities, know the similarities, know the differences. All these drugs are, I said, put nucleoside / nucleotide analogs. In biochem, we just touched on this. We gave you examples. What are nucleotides? They are chemically synthesized, and they resemble the naturally occurring nucleotide and nucleosides. And the enzymes, not knowing the difference, they think this chemical is a natural analog. They put it into chain elongation to make a DNA, to make an RNA. And once this one is assembled, then the incoming nucleotide cannot bind to it. That is the whole thing about how these nucleotides are made. So they will be either what is essential to build an elongated chain. The terminal nucleotide should have a 3' hydroxyl group free. If it is DNA, it's a deoxy. But the 3' hydroxyl group is so critical in a sugar molecule for the incoming nucleotide. If there is a free 3' hydroxyl group, then it can make a 3' phosphodiester bond. Remember, all the nucleotides are joined together by phosphodiester bond between the 3' hydroxyl group of the previous nucleotide and the 5' hydroxyl group of the incoming nucleotide. If you omit that 3' hydroxyl group, or you put a methyl group in some cases, the incoming nucleotide cannot bind. The enzyme cannot put them together. Therefore, what's the result? The result is termination of elongation. So the viral DNA, viral RNA cannot be elongated, and therefore the RNA the virus cannot replicate. is the chemistry part, that if you know those things, little hydroxyl group here and there, and any addition or omission of a 6-member ring of the purine base, that makes a whole big difference. Okay? Then we will talk about these 4 chemical structures. Then we will talk about immunomodulators. Immunomodulators are interferons. You already know, probably we talked about, I did, last week, interferons. We talked about interferons, 2 kinds of interferons. What is the role of interferons? Interferons are neuromodulators, immunomodulators. They are produced in the infected cell, and they are released to the niche. And these interferons will provoke the immune response in the neighboring cells. Hey, there is a danger coming in, get prepared. That's what these immune modulators' role is. And in interferons, we will talk about what are they. Those are proteins. As proteins, they are subject to protease degradation. Proteases are all over in the extracellular fluid, and they will degrade these interferons. So how can you make them stay longer? That is the pharmacist's knowledge. So we can add an inert material attached there to the interferon that will make interferon stay longer. Proteases got confused. Now proteases cannot touch this interferon. They are called pegylated. So polyethylene glycol is one of the inert material they will be attached to. And as a pharmacist, you should also know that interferons, you cannot give tablets or oral administration. Interferons just cannot go because these are proteins, and they will be destroyed in the stomach acid. So it needs infusion. So you either IV or subcutaneous based on the size of the molecule. So those are the things which you need to know, the chemistry part. Okay? Let's go to I think I have the tenofovir first. It is a nucleoside-nucleotide analog. By looking at the structure, who can tell me, is it a nucleoside or a nucleotide? Remember in your biochem, we told you what is a nucleoside, what is a nucleotide, the difference. If you remember anything that subsequently probably Dr. Selvon may have touched on these nucleotide analogs in some of your PODA classes. 1, 2, 3, he does, or Dr. Milton does. So, is it a nucleotide analog or a nucleoside analog? That's it. Okay, how many agree with her, with them? 2, 3, 4, and you also agree with yourself, right? You're 5. Then who else think it is nucleoside? Who do not agree with her? We both. We are learning here. Who thinks it is not a nucleotide? So you need to remember this coming from the first semester. Now we are in the 6th semester. So it is a while. The difference is, to be a nucleotide, it has to be a base, sugar, and a phosphate group. That becomes a nucleotide. Can you see a base? Of course. A sugar looks like a sugar. It is not a sugar. And what about a phosphate? There is a phosphate. So it makes a nucleotide analog. And there is no sugar. So that makes it unnatural, or but it is not the right entity, nucleotide analog or naturally occurring analog. Therefore, it will be incorporated, and there is no sugar, ribose, Therefore, there is no 3' hydroxyl group for the incoming nucleotide to bind to. So it will terminate the elongation process. Okay? And it is a purine analog, and it is nucleotide because there is a phosphate group, and it is a prodrug. It is a prodrug because there is something attached to these phosphate groups. Remember, phosphate groups, we said at neutral pH, the hydroxyl group ionize. They get negative charges. And we also talked about nucleotide phosphates and triphosphates. They will even have more phosphate groups, therefore more negative charges, which repel each other and make the ATP cell vulnerable, kinetically unstable, and it gets, we wanted to get rid of the pyrophosphate, becomes AMP. So any nucleotide analog, it should be an a monophosphate. You cannot put a diphosphate or triphosphate into the system because they ionize. The moment they ionize, their absorption is hindered. So it is as a monophosphate, they protected the hydroxyl groups from ionizing by putting this, a complex molecule called the 2-pivolyl oxymethyl. These are methyl groups. It is a C, CH3, CH3. So they have put all kinds of the molecules in there. They're making it unionized, therefore it gets into the system. And it is a prodrug because it has extra molecules, that's a pivolyl C methyl group. It will be metabolized the moment it is enters the system. It will be removed. This pivolyl methyl C group is removed, and it becomes a tenofovir with the purine rings, and there is a methyl group, and then a non-cyclic monophosphate group. Then the cellular kinases, remember it is only a monophosphate. Then all the kinases, they phosphorylate this, and it becomes a triphosphate. Tenofovir diphosphate, and because it has already one phosphate group, so it is actually a triphosphate. It is similar to naturally occurring purine analog, a nucleotide. But it is not natural because there is a methyl group, there is no ribose sugar. Okay? What happens is, if this is incorporated, it makes a diphosphate or a phosphodiester linkage. Then there won't be another nucleotide to come in because there is no ribose 3-phosphate, 3-hydroxyl group free, so the elongation is terminated. And that causes the viral replication to a halt. So therefore, tenofovir acts like a nucleotide analog. It comes with these diisoproxyl, and it is a prodrug because it is injected or it is internalized as a prodrug, and it is the prodrug's extra groups are removed and becomes tenofovir. It is the active drug. The active drug undergoes phosphorylation and becomes a tenofovir diphosphate, a nucleotide similar to a naturally occurring nucleotide, and when it is incorporated into the growing chain of the RNA by RNA viruses or DNA replication, then it will stop the incoming nucleotides, so elongation is stopped, the replication of this RNA is stopped. And this drug is used for treating hepatitis B virus cases. Therefore, B is a DNA virus, and it has a low affinity to human DNA polymerases. Remember, human DNA polymerases are different from RNA polymerases, also viral polymerases. And it doesn't affect the host cell DNA replication. So what do you have to remember in this? You don't need to remember the whole structure, but I'm asking to find out why it cannot elongate the chain. It is because of the absence of 3-hydroxyl group, absence of ribose sugar with a 3-hydroxyl group free, and it is just a non-cyclic methylated derivative of purine molecule. What about adefovir? It's also used to treat the hepatitis B virus. Now, looking at the structure of adefovir, what do you think? Is it a nucleotide or is it a nucleoside? I'm sorry? Nucleotide. Because you see the base, and like tenofovir, there is no ribose sugar, but it is a non-cyclic chain, and it is phosphorylated, monophosphate. Therefore, it is a nucleotide. It resembles the structure of natural adenine monophosphate, but does not contain a CH3 group in the acyclic chain. Unlike tenofovir, there is no methyl group in the non-cyclic chain. So that's the difference between tenofovir and adefovir. Both are nucleotides. Tenofovir has a methyl group, methylated non-cyclic chain, whereas adefovir doesn't have that methyl group. And both have this dihydroxyl groups. Remember, tenofovir also has it. So they both are prodrugs. They contain the same dihydroxyl group. So similarity. Both are similar in that respect, but adefovir doesn't contain the methyl group, whereas tenofovir does have a methyl. And both of them do not contain a ribose sugar. Therefore, they are unnatural. Again, the mechanism is same. They will be incorporated, they will be metabolized. The dihydroxyl group is removed, and it becomes the adefovir active drug, and it is phosphorylated to the NTP, and the enzymes, the virus enzymes think that is the natural purine analog, and they incorporate it, and the elongation gets halted because there is no ribose sugar free hydroxyl group at 3 position. There is no ribose sugar at all. So the mechanism is same, halting the elongation of the hepatitis B virus DNA molecule. The benefit of adefovir is that over the lamivudine, they do not develop resistance for adefovir. So the hepatitis gets killed and they do not get resistance. But in case of lamivudine, they do get resistance. We will see why they get resistance. Any questions on these two drugs? Again, list the similarity, list the differences. Now look into the structure. What is the prodrug? What is the active drug? Now, chemistry of entecavir. It is a guanosine nucleoside. So it is a purine nucleotide, like adenovirus, tenofovir. However, look at the structure of this cyclopentyl group. This looks like a ribose sugar with a 3' hydroxyl group in it, but it is not a ribose sugar. It is a cyclopentyl ring structure. The viral enzyme doesn't know that difference. It thinks it is and by the way, is it a nucleotide or nucleoside?
Nucleoside.
It is a nucleoside. There is no phosphate in this. So the enzyme thinks it is the right or the natural nucleoside. It gets phosphorylated by kinases, so it becomes a nucleotide triphosphate. When it is incorporated into the growing chain of this viral DNA or viral mRNA molecule, chain elongation stops. Because it is a cyclopentenyl, it is not ribose sugar. That's one mechanism. Being a guanosine base, remember there is when the mRNA is formed, the leftmost guanosine, the mRNA undergoes post-transcriptional modification. It is again your first semester biochem. There will be a cap at the left side of the first guanosine base gets a cap, and at the 3' end it gets a polyadenylation, adenylation. So that's the orientation. When this mRNA is used to make a protein, it makes the orientation guanosine. The cap is always at the left. That's where the protein synthesis starts from, the leftmost. The guanosine starts from there. The cap orients the translation process, and the polyadenylation, the 3' hydroxyl, stops the protein synthesis. Now, because this guanosine is not able to get a cap, the translation of the protein stops because virus doesn't know where to start the protein synthesis. So capping process is interfered, whatever you can call, inhibited. Therefore, this guanosine nucleoside analog acts like a inhibitor of HBV polymerase or reverse transcriptase. It inhibits elongation of DNA. It inhibits the protein synthesis because there is no cap in the mRNA. So it competitively inhibits HBV polymerase. To do this, base priming, that is capping the guanosine, reverse transcription of mRNA, and synthesis of HBV DNA. All three processes are critical for the virus, therefore viral death is certain. So it inhibits all three processes. So what about lamivudine? Chemistry of lamivudine. It is a What is this base?
Nucleoside.
It's a cytosine molecule, right? It is the pyrimidine, right? And it has looks like a ribose sugar, but it is not a ribose sugar, and it's a hydroxyl group, and therefore there is no phosphate, so it is a nucleoside derivative analog, and it is also used for hepatitis B virus, and it inhibits the B virus polymerase. This lamivudine is also used for HIV, to treat HIV/AIDS patients. Something unique for this molecule is presence of a sulfur atom in this the cyclopentyl ring structure. There is no hydroxyl group in here. Okay? It lacks 3' hydroxyl group, and it has this thiol group in it. That makes it is a prodrug because it requires phosphorylation. Okay? So if the phosphorylation occurs once it goes into the system, then the phosphorylation occurs. Therefore, it is a prodrug. The active drug is the phosphorylated lamivudine. It has thiol groups, and it lacks 3' hydroxyl group in this cyclopentyl functional group. Therefore, unlike the natural cytidines, which is required for the DNA elongation, this will get stuck. It comes in between elongation. Subsequent elongation processes is halted. Therefore, no DNA is synthesized. Any questions? I think that would be about the nucleoside antiviral drugs. 4 of them we talked about. Know those differences where there is a nucleoside. These are simple questions I can throw in just to know the chemistry of these drugs. Okay. Now the immunomodulators, interferons. As I mentioned in the previous class, interferons, they possess antiviral, immunomodulatory, and anti-proliferative activities. These are proteins. There are 3 major classes of interferons: IFN alpha, IFN beta, and IFN gamma. IFN alpha and beta are produced by all host cells in response to viral infection. They possess antiviral, anti-proliferative activities. Only IFN gamma is produced in T lymphocytes and NK cells, natural killer cells of the host. IFN gamma has less antiviral activity. IFN gamma possess other functions such as immunoregulation and the macrophage activation, but it is not an antiviral agent, IFN gamma. IFNs act mainly by downregulating production of various cellular proteins. So that's how they immune modulate the cellular functions. They are administered either by subcutaneous or intramuscularly. Because they are proteins, you cannot give as oral doses because they will be destroyed in the stomach acid. So therefore, they need to be infused or subcutaneously or intramuscularly. As proteins, as I mentioned earlier, they are short-lived. How can we prolong their half-life? We can prolong their half-life by attaching an inert material such as polyethylene glycol. Polyethylene glycol is repetitive. The molecule, the structure keeps on repeating, and you can make a chain elongation like 40,000 Daltons or 30,000 Daltons. Because this is a protein, we calculate the molecular weight in Daltons. Or you can say kilodalton or Dalton. That is the unit we use. And if you attach the polyethylene glycol, depending on the number of polyethylene glycol, then the process is called pegylation. So the pegylated interferons live longer, their half-time is prolonged, therefore they can elicit their immunomodulatory functions, therefore they act as better antiviral agents. Two kinds. There is a PEG interferon alpha 2A, PEG interferon alpha 2B, and generic name they call them different, Pegasus and PEG interferon. The PEG IFN alpha 2A is an ester derivative. Here is the chemistry. It is an ester derivative of a branched chain polyethylene glycol. Look at the plasma half-time, it's extended to 80 to 90 hours. Whereas IFN alpha 2B has a straight chain, it is not a branched chain. So that's the difference between PEG alpha 2A and PEG alpha 2B. PEG alpha 2A is a branched chain molecule, whereas the PEG alpha 2B is a straight chain molecule. It has less number of the PEG units, PEGs, so its molecular weight is lower. Its half-time is also lower. It looks like there is a positive correlation between the number of PEG units attached and the half-time of the IFN. The more number of PEGs attached, it will prolong the half-time. PEG 2 alpha, 2A is more stable. The branched chain is more stable than the straight chain. While PEG 2 and 2B requires, so this is about how they are dispensed. PEG 2 alpha is more stable and dispensed in solution, comes with the solution, whereas the other one, 2B, comes as a powder, so you need to reconstitute just before the injection. Yes.
I do know that in your previous lecture, when you discussed pegylation, there was you explaining the longer half-time up to 168 hours.
Yeah.
I know now we're going into the 2 alpha and the beta.
Yeah.
But how do we incorporate that half-life? I guess like what is that?
Depending upon the number of this kilodalton, the molecular weight. Higher the pegylation, higher the number of PEG molecules attached to the IFN alpha, it increases the half-life. In there, I think the molecular weight is much, much higher.
Oh, I see.
That's why you can go up to 160 hours the half-time. So you can increase the half-time by adding the PEG units. More PEG units, more number of PEG units, more the half-time. And the branched chain needs to be, it comes in solution, whereas straight chain comes in powder, and it requires reconstitution. It is more like a pharmaceuticals question. Now, how do we treat hepatitis C? What's the difference between hepatitis B and hepatitis C virus?
It is the RNA virus.
One's RNA, one's DNA.
Yeah, which one is DNA?
Hepatitis.
B is a DNA and C is an RNA virus. Thank you. So again, there are antivirals nucleoside and nucleotide analogs for this hepatitis C. Also, they have the interferons, immunomodulators. The antivirals are these three: sofosbuvir, cimetprevir, and ribavirin. And we are going to talk about chemistry of these three. Interferons, I think whatever I said, I suppose good for this also. They are the same interferons, alpha and beta. Chemistry of ribavirin. Look at the structure, and it is a nucleoside analog. Unlike adafovir, tenofovir, look what they did. Here is the pyrimidine ring structure. I'm sorry, this is a purine ring structure. There is an imidazole, the second ring is intact. Look at the 6-membered ring. There is no 6-membered ring. They just attach a carboxamide group into it instead of a 6-membered ring. The base is altered here, and they kept the ribose sugar moiety intact. It has 2' hydroxyl group, 3' hydroxyl groups are intact. It is a prodrug because it needs to be phosphorylated. It comes in as a nucleoside analog and requires phosphorylation. Therefore, it is a prodrug. It resembles like a guanosine. Again, it will be interfering with the caffeine. So the guanosine, it is not a true guanosine because the 6-membered ring is absent. And the other difference is it is a carboxamide. That is the structure of ribavirin. But there is a better prodrug, taribavirin, but it is not in the, it is not FDA approved, but it is going through the clinical phases, phase 3. But just for your information, look at the structural difference. Instead of a carboxamide, they made NH2. What do we call this? It is a carboxamidine. So they found this one is better than the ribavirin, but the ribavirin is the one currently in use, and it is FDA approved. So just to give you a heads up, you probably may see this coming in later on. But the ribavirin is an analog of this guanosine, nucleoside. Therefore, it interferes with the mRNA replication. Because there is no 6-membered ring, the capping process is inhibited, and it will interfere with the RNA replication. The guanosine, depending on its rotation and pairs equally well with either uracil or cytosine, inducing mutations in RNA-dependent replication in RNA viruses. Remember, it can be uracil or it can be cytosine as well. It can be converted too. So that is the mechanism how the ribavirin is active. It is a prodrug, and it interferes with the mRNA replication. Therefore, it is used to treat hepatitis C virus. The second, there is the cimetprevir, but it is out of the market. There is no, it was voluntarily withdrawn. That's what it said in 2018. So we don't have to talk about it. and we're going to skip it. Then the last one is a sofosbuvir or sovaldi. Again, it is a prodrug. Look at the complex nature, and it is a nucleotide because there is a phosphate group. There is a ribose sugar, however, it is methylated. One of the carbons have a methyl group in it, 2' methyl group, and a fluoride in it. So there is no 2' hydroxyl group in this. But there is a 3' hydroxyl group intact. And what do you call this base? What is this structure? It's a uridyl nucleotide, contains a uridine base. Now they protected the phosphate group from ionization by adding a aromatic ring structure into it. Therefore, it won't ionize. So they prevent ionization, and therefore it will be taken up across the membrane. So they prevented the hydroxyl group from ionizing by adding an aromatic ring, as I have mentioned here. So it will not make a negative ion. The ionization I refer is a PO4 minus. That's the one we are talking about. So that will prevent ionization. And also they put a methyl group at the 2'. This will, what happens is, this molecule is mistaken by the enzyme, and it will be incorporated into the growing chain of the RNA. Once it is incorporated, the incoming nucleotide cannot bind to it, even though the 3' hydroxyl group is free. What happens is there is a steric hindrance, steric clash. That's what it is. By having a methyl group next to the 3' hydroxyl group, the incoming nucleotide, natural nucleotide, will not bind to it because the methyl group prevents it from binding to the 3' hydroxyl. That's how it terminates the elongation process. So lack of the ionization will make the drug go into the system, facilitate entry of the drug into the infected cell, and having the methyl group in the ribose sugar will prevent the chain elongation process because of the steric hindrance or steric clash. There is some more on this details of the metabolism, but I don't think you need this. This is how the metabolic activation occurs. Here is this sofosbuvir, a prodrug, gets into the cells, enzymes will activate it, remove the benzene ring, and the phosphate is free. That phosphate group is phosphorylated further by kinases to give you the active triphosphate molecule, but this is not a natural molecule. Therefore, when it binds to the mRNA terminal sequence, it will prevent elongation because there is a methyl group at the second position. It will hinder the phosphoester bond formation at 3 position. You don't have to remember any of these enzymes, just ignore it. Just to give you clarification how this is activated by phosphorylation. So these are the 3 molecules which you need to know, which are used for treating the hepatitis virus, C virus. Remember, A, B and C are the chronic, they are the troublesome, whereas D and E are not. A, B, and E hepatitis viruses are not so bad for the human. Only the B and C are, they require treatment. Okay? Any questions? These are simple things of the, you need to know, you call back your biochem knowledge, molecular biology, what a nucleotide is, what a nucleoside is, what is the activation step is. These are the critical things, and how do we block the elongation process? Either omit the different hydroxyl groups or make a replace a cyclopentenyl group with for a ribose sugar, or put a methyl group in case of this compound here, so that the incoming nucleotide cannot bind to it. So those are the tricky things. Chemically, you do manipulate the drug. That way, you cannot have the virus. Okay. That's all I have, unless you have questions. There are 9 questions from this section because I just have one class for the next, is that for exam 5? Yeah, exam 5, 4 lectures from Dr. Zhang and 1 lecture from me. So it is again 9 questions per lecture. So 9 times 5 is 45 points, 45 questions for the exam 5. Anything else?
But you said we don't have to know that slide, that's just for clarification.
Yeah, this is just for mechanism. I do for details. I gave you this to explain it, how it is modified, phosphorylated, etc. If you, yeah, this slide is important. Okay. Now, earlier, since many of you came late, I said I went ahead and reviewed my 18 questions for the exam 4. My side was 18. So out of 18, there were 3 questions ambiguous, I felt. So I modified it, adjusted grades, and there are 78. It improved your grades for this 18 questions. Other questions, you need to approach the faculty who wrote those questions, get clarification from that faculty. It is not appropriate for me to go in review for the other faculty's questions. Okay? I agree with you. We all got your class reps email asking to review those questions. But she did not include mine. I think I already told her that there are 3 questions yesterday after the exam. So that's why I didn't get anything from the class rep. But I just went there and adjusted it. So that is taken care of.
Thank you.
Thank you.
Okay.
Thank you.
And is your exam 3 grades out in Blackboard?
No.
No, okay. No, I brought that to the course coordinator's notice. Course coordinator is Dr. Mo. You all know that, right? Yeah. Please ask him. Direct your question to him and get the clarification. I'm sorry.
What was the question?
Okay.
We can mention that.
Yeah, I hear you. But, yeah, be persistent. Don't give up. Okay? Yeah. Make a note. You said you will forget the question. Please write down the question. What is that you need to ask?
Our discussion paper, where we can write it. So, I know it was, some question was, had a mistake in the question, but right now I cannot remember which question was that.
Yeah, as a faculty, it's my responsibility to go look into it. As soon after you take the exam, that's what I do. What I normally do, I don't wait until you ask me. I know my mistake, I just go ahead. If there is my side, I will just accept it. There is no ego involved. Nobody is perfect. Yeah, what is
Oh, I was gonna say thank you for always being very
Ah.
understandable to
Oh, okay.
students and always so
It's my
responsible.
job. It's my job. I'm not doing any favor to you, but it is my job.
Yeah.
All right, have a good one. We will in the exam.
Thank you.
Sure.
Yeah, and they did it.
Okay, if I leave by 7.
Because we're switching, and they always give us the.
Yes.